Write the partial fraction decomposition of the given rational function, rational expression. X over x plus 5 times x minus 2. To write a partial fraction decomposition, you want to make sure your denominator is in factored form, and luckily this one is. And then you want to pay attention to what type of factors you have, because the type of factors you have helps you determine what kind of setup you're going to have. So with this first factor in the denominator, this is a linear factor. And the reason why I know it's linear is because it has x, and x is to the first power. So with a linear factor, you're going to have a fraction with a constant as the numerator. The next factor is also linear, and we'll set the next fraction up in the same way. So both of these factors in the denominator are linear factors, and they each get their own fraction with a constant in the numerator. I use the letter A and B for those constants. You can use other letters as well. You just want to make sure you have them being different, since those numerators can be different. So the next thing we want to do is we want to try to solve for this A and B. So to start solving for that A and B, we want to clear out the fractions. We're going to clear out the fractions by multiplying by the common denominator on both sides. So on the left, we're multiplying by x plus 5 times x minus 2, and we'll multiply the same thing onto the right, x plus 5 times x minus 2. So on the left, x minus 5 cancels, x minus 2 cancels, and we have an x on the left. On the right, we're going to use our distributive property and multiply this common denominator by each term. So we have a over x plus 5 times x plus 5 times x minus 2 plus b over x minus 2 times x plus 5 x minus 2. And we have some canceling that happens here as well. X minus 5 cancels from the first term, and x minus 2 cancels from the second term. And that leaves us with the equation x equals a times x minus 2 plus b times x plus 5. Now we want to solve for a and b using something called equating the coefficients. So to equate the coefficients, I want to simplify the right-hand side to have like terms together. So let's distribute the a. That gives me ax minus 2a plus bx plus 5b. Then I'm going to group the like terms together. So that's ax plus bx, those are like terms, plus 5b minus 2a. So 5b and 2a, those are the constants, so we group them together. So on the right-hand side, I can also write, we can factor out the x, and then we have a coefficient of a plus b on the x term. So we're going to do something called equating the coefficients. So what I'm thinking on both sides is that I have a factor of x and a constant. So on the left, even though I don't have a constant there, I'm going to treat this as 1x plus 0. On the right, I have a coefficient of a plus b on the x term, and a constant of 5b minus 2a. So since the like terms have to equal each other on both sides, I'm able to create a system of equations with this. So the coefficient on the x for the left should equal the coefficient of x on the right. Those like terms should be equal to each other. So for my system, my first equation is that 1 equals a plus b. Then for the second equation, my constant on the left should equal my constant on the right. So my second equation is 0 equals 5b minus 2a. Then I want to try to solve that system of equations, and we've learned a bunch of different ways to do that. I'm going to try substitution. So with the first equation, I have 1 equals a plus b. I'll subtract b on both sides. That's a equals 1 minus b. And then I'll substitute that into the other equation. 0 equals 5b minus 2a. So I'll substitute 1 minus b in for a, giving me 0 equals 5b minus 2 times 1 minus b. This is 0 equals 5b minus 2 plus 2b. I can combine like terms to give me 0 equals 7b minus 2. I can add 2 to both sides, giving me 7b equals 2. And I can divide by 7 on both sides, and I now know that b equals 2/7. Now I can solve for a. I'll substitute this 2/7 in for b, and that gives me that a equals 1 minus 2/7. I'll get a common denominator. 7 over 7 minus 2 over 7 is 5 over 7. So a is equal to 5 over 7. Now that I know what a and b are, I'm going to be able to write my partial fraction decomposition. And you want to go back to your original way that you wrote this expression out. So we said, to start off this problem, that x over x plus 5 times x minus 2 was a over x plus 5 plus b over x minus 2. And then we found a and b. And we found a to be 5/7 and b to be 2/7. So we're going to replace that a with 5/7 and replace that b with 2/7. So the partial fraction decomposition for x over x plus 5 times x minus 2 is 5/7 over x plus 5 plus 2/7 over x minus 2. Graph each equation in the system. Solve the system to find the points of intersection. So we have a system of nonlinear equations here. Looking at the first equation, I have x squared plus y squared equals 16. This is the format of a circle. So that first equation is a circle with center 0, 0 and radius of 4. The second equation is a little bit harder. It's not in the exact circle format, the standard form of a circle. It's in the general form of a circle. So I can use completing the square on this group of x terms to help me figure out the standard form of that circle. So I would start with the coefficient on the x, which is 4, and I'm finding the magic number 4 over 2 squared. So I started with 4, cut it in half, then I want to square it, so that gives me 2 squared, which is 4. So I'm going to take and add 4 to that group of x's, and whatever I do on one side of the equation, I have to do the same thing on the other side. And then the x group is going to factor into x plus 2 squared. And now I can see that this is a circle, and its center is -2, 0 with a radius of 2. So both of these are circles, and I'll graph them on this picture. I have one circle with center at 0, 0 and radius 4. So the first equation has a graph like this. The second equation has a center at -2, 0 with a radius 2. I'll go 2 in each direction. And I'm looking for the intersection point to solve the system, and we have an intersection point right here at -4, 0. Now that is visually the intersection point, but we can also solve this system using substitution or elimination. So I'm going to try that as well. So we have the system, which is x squared plus y squared equals 16, and x squared plus 4x plus y squared equals 0. And if I multiply a negative onto the second equation, x squared plus y squared equals 16, the negative on the second equation, it becomes -x squared minus 4x minus y squared equals 0. And then I add these equations together. The x squareds eliminate, the y squareds eliminate, and I'm left with -4x on the left. And on the right, 16 plus 0 is 16. And I can divide both sides by -4 and get x equals -4. So that gives me my x-coordinate of the intersection. To get the y-coordinate of the intersection, I can substitute this into either equation. So I'll substitute it into x squared plus y squared equals 16. So in for x, I put -4. -4 squared is positive 16. I subtract 16 on both sides. That gives me y squared equals 0. And when I square root both sides, I get y equals plus or minus 0, which is y equals 0. And we get the same intersection point that we got visually with the graph. -4, 0 is the solution to the system. Graph the inequality. This is a nonlinear inequality, and I'm going to solve this inequality by drawing a picture. To draw the picture, we first want to graph the boundary. And the boundary is replacing that inequality symbol with an equal sign. So that becomes y equals x squared minus 2. Now this is the equation of a quadratic, which has a graph of a parabola, and the parabola is shifted down 2 units. I'm going to graph this boundary line with a solid line because the original inequality has an equal to. So I'm going to start at 0, 0, shift down 2, that's where my vertex is, and draw the graph of my parabola. Then I want to draw the shading. To draw the shading, you're going to choose a test point. And most people like to choose 0, 0 as the test point. The only rule with a test point is that you must pick a point that's not on the line, not on the boundary. So you're going to take that test point and substitute it into the original inequality. So 0 is less than or equal to 0 squared minus 2. That 0 is less than or equal to negative 2. And that is a false statement. So our test point came out false. And that means all of the ordered pairs that are on the same side as that test point will also be false. We want to shade the side that contains true statements. So that's going to be the other side of the boundary line. So we're going to shade this side that does not contain the test point. So the boundary line of the parabola, and all of these points that are below the parabola are solutions. And I guess if we continue to draw the parabola here, it's not just under the vertex, but also these points here. Those are all solutions to the inequality y is less than or equal to x squared minus 2. Evaluate the factorial expression. Factorial is this exclamation point. That's the symbol that we use for factorial. The meaning of 5 factorial is 5 times 4 times 3 times 2 times 1. So you start with that number and you multiply by 1 less than that number until you get down to 1. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. We have some special definitions. 1 factorial is 1 and 0 factorial is 1. So to work out this example, I'm going to write 5 factorial times 7 factorial over 2 factorial. And I'm going to write these out and do some canceling. So this is 5 times 4 times 3 times 2 times 1. 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. So the 2's will cancel. The 1's will cancel. And then we just have to multiply the rest. And multiplying this out in a calculator would give me 302,400. There's also a factorial button on the calculator. So we can go into, first we want to type 5, and then go into the math menu, and go over to probability, and number 4 has that factorial symbol. So we want to do that times 7 factorial, so math menu, over to probability number 4, and we want to divide that by 2 factorial. Once again, back to the math menu, over to probability number 4. And we've got our answer of 302,400. We want to write out the sum. This is our summation notation, or sometimes called sigma notation. This symbol here is a Greek letter sigma, capital letter sigma, and it's what we use to add. Now this summation notation or sigma notation tells us the starting point and the ending point of our sequence. So our sequence starts at 1 and it's going to continue till n. Now n is an unknown, and so we're going to have to use some ... dots to say the pattern continues, but we are going to start at 1. So we can get the first term in the sequence by substituting 1 into the expression. We get 1 squared over 4. Then the next term, we'll substitute a 2. That would be 2 squared over 4. And then we're going to use our ... to say that the pattern continues. And it's going to continue until we get to this top value of n. So we'll substitute n into our expression and get n squared over 4. Now let's simplify. 1 squared is 1. So our first term is 1/4. Our second term, 2 squared is 4. So we have 4 over 4. And we have 1 as our second term. So this is how we write out the sum using sigma notation. An arithmetic sequence is given. Find the common difference and write out the first 4 terms. Let's write the first 4 terms of our sequence first. So I'm going to call this sequence A sub n, and the first term of our sequence will be A sub 1. We're going to get that term of the sequence by substituting a 1 into this expression. That's negative 2 minus 9 times 1. That simplifies to be negative 2 minus 9, which is negative 11. The second term of our sequence will be given by substituting a 2 into our expression. It's negative 2 minus 9 times 2. That's negative 2 minus 18, which is negative 20. Our third term of the sequence we get by substituting a 3. That's negative 2 minus 9 times 3, which is negative 2 minus 27, and that's negative 29. The fourth term of our sequence is negative 2 minus 9 times 4. Negative 2 minus 36 is negative 38. So we can write our sequence as negative 11, negative 20, negative 29, and negative 38. And then use and so on to say that that pattern continues. Now the common difference is when we take consecutive terms and we look at the difference of those consecutive terms. So if I look at the difference of the first 2 terms, taking negative 20 minus negative 11, that's negative 20 plus 11, we get negative 9. And if we take a look at the next 2 terms and take their difference, that's negative 29 minus negative 20, which is negative 29 plus 20, and that's negative 9. If we take a look at the next pair of terms, we have negative 38 minus negative 29 is negative 38 plus 29, and that equals negative 9. So you can see that the difference between these consecutive terms are the same or in common. So the common difference for this arithmetic sequence is negative 9. So we say that D is negative 9. Now if you're familiar with the format of the nth term of arithmetic sequences, you know that the coefficient on n will be the common difference. So you could have gotten the common difference if you knew that pattern.